There are several types of descriptive research. We looked at the surveys as one type of descriptive research. We also looked at the developmental studies, where we looked at several types of developmental studies. We looked at longitudinal studies. We looked at the cross-sectional studies, follow-up studies, trend analysis, content analysis, questions. Are we happy with what we talked about? Or we are angry with what we talked about? If there is any anger, where is it from? Hey, there is a serious quietness. What does this quietness mean? Are we happy? Are we sad? Oh, if we are sad, where exactly are we angry about? It is hot. Oh, hot? Okay. When somebody says hot is style. What about for service? Are we happy with that? No. Yeah, where is the problem? What is it that is causing a problem about service? Is it an issue of sample surveys versus the census surveys? Is it an issue of tangible variables versus intangible variables? Is it an issue? What is the problem about surveys?
Yes, the difference between cross-sectional
Or the difference between cross-sectional studies and the longitudinal studies is the problem. Okay. Another problem, at least one area of concern is clear. What is another area of concern? The main difference between longitudinal studies and cross-sectional studies lies in the fact that for longitudinal studies, you choose one group of people and you study that group of people over an extended time period. As the time is going by, you want to be assessing how the particular variable of interest you're looking at is changing with their growth, is changing as the people are developing. So one group over an extended time period. And you want to see how the variable you're looking at is changing in that group of people. Now we saw that Using that approach, the major challenge is how to make sure that that group you are studying remains the same. You'll be experiencing loss of subjects. Maybe some people will be moving away. Some people will be dropping for various reasons. So that will be one problem you are likely to experience with from children studies. There's also another problem that you as a scientist will require to stay with the group, to study the group for that long period of time. So your commitment to the group is wrong. You need more resources to keep you going with the study, to keep you studying the group for a long period. So with those challenges, we said that another way of studying variables over time would be to take several groups which are at different developmental stages, and you study the variable among these groups, and your aim is to see whether there are differences between one group and another group. When the groups are at different developmental stages, you want, if you see any differences, you want to associate those differences with the differences in development of these people. So, and I was giving an example. If you want to assess a achievement in a particular subject in students, and you want to see how the students are change in their level of achievement as they are developing. So you may take students at different levels, grade 1, grade 5, grade 8, and you assess their achievement at one time. Your hope is to see whether the grade 8s have a different level of achievement to the grade 5s, whether the grade 5s have a different level of achievement to the grade 1s. And if you find that difference, your aim would be to associate that difference with the level of development of these people. But then we saw that the challenge with that is that you may experience other extraneous variables that may influence the same achievement. If the grade 8s were naturally better students than the grade 5s, now if the grade 8s are achieving high, is that high achievement because of their development or because they are generally higher achievers? You may not be able to answer that. If the grade 8s are taught by a much better teacher than the grade 5s, and you find that the grade 8s are achieving much better than grade 5s, is that because of their developmental level or because of the teacher effect? So extraneous variables become a problem when you are dealing with the when you are using cross-sectional studies to assess the level of achievement. So, but still, if you are able to control these extraneous variables, you can use cross-sectional studies. And at the conclusion of our discussion, we said that when your interest as a researcher is to really look at the change that is occurring as people develop, you are better off using longitudinal studies. But if your interest is to look at the typical differences for different age groups of different developmental groups, then you can use cross-sectional studies. I don't know whether we have become friends now. Other concerns? Happy and happy. Happy. Yes. Okay.
I don't know if it's just me or I'm just confused. The types of research design. At first, we have to look at descriptive, and then the second one was experimental research. Now we have done the descriptive research and the development. So I don't know if I'm confused. Maybe the others are different because the content I have in the first descriptive research and the second one is kind of different. So I don't know if it's the same thing or
Yeah. Her concern is the confusion she is getting the same as the rest of the people, and the other people seem to be happy. Can you answer her question? You know, but she wants to be helped. You don't want to share the knowledge you know? Madam, can you answer her question? No, her question is, when we started off our discussion, we started off by saying that research varies from descriptive to experimental. Now we started talking about the descriptive. And then in the process, we've talked about surveys, we've talked about the longitudinal studies, we've talked about cross-sectional studies, follow-up studies. Hey, what's not happening here? So she wants to know what is happening. Hey, that's the anger she has. So I'm asking you to bail me out from her anger. And these two have not bailed me out, but she can bail me out. Hey, she doesn't want to bail me out. Who wants to bail me out? Yes.
From our discussion, we said descriptive research, right? These
Yeah.
are research that we usually use on current occurring situations. So if I go back to the notes, these are conducted to get information on current events and status of the phenomenon. So just descriptive and measuring types of research that are just there to observe what is happening and then it's supposed to give back feedback. And whilst experimental research, these are active research to go back to the beginning, where you as researchers you are supposed to conduct experiments, like to come up proving hypothesis, research, proof of point, like this, like those research that we did, same apply why as the types of research, those are one of the experiments. We try to find out what is the problem, and find out we answer the problem and have solutions. So that's like different. We're just analyzing information like this and giving out feedback. And then the experimental ones are trying to come up with solutions at the end.
Well, we started off well, but somewhere on the way we got lost. Um, your question is about what I say. When I was talking about the difference between descriptive and experimental, I said that the research varies from descriptive to experimental in a continuum. So there are studies which are purely descriptive, but some of the studies you conduct will be moving towards that. And then the other studies will be purely experimental. Such that what we have been doing since we started discussing types of research, we have been going along this continuum. We are moving towards that side, but we have started from that side. But what he started off by saying is exactly what we said, that when you are doing descriptive research, your interest is to describe the status of a particular phenomena. And you basically deal with the question, what is the situation? What is the status? So you want to describe what the situation is. An economist might be interested to assess the economic status of people living in Area 15. Now, if you want to assess the economic status of people in Area 15, basically you're asking the question, what? What is the economic status of people living in Area 15? So you go, you look at their income levels, you look at their food security status, you look at their assets and things of that nature, and you can come back and say, people in Area 15, their economic status is like this. You are just describing it. But you can start moving from descriptive, going this direction, right? And ask another question to say, why? I think he went to that level. Why is their economic status like this? Now you want to start explaining. You are not just describing, you are going towards explanatory studies. I don't know whether we are moving. So in the discussion of these various designs, we have already started working on this continuum. And one day, actually, we are very close to this side. Because from whatever we have talked about, the next thing I am going to talk about today is correlational studies. And correlational studies are way towards this. They are not this, but they are way towards yes. So okay, sorry. Some of you are not asking. But when your colleagues ask, you are not able to answer them. What's the problem? Should I start asking my questions? And let's see whether your silence is a genuine silence. Okay. So we've talked about the descriptive studies. Remember, we said that when we say descriptive studies, it doesn't mean that there is no quantitative analysis. There is a usual confusion, people thinking that when we are talking about the descriptive studies, then it's just describing. No, but if you want to describe the income status of people in Area 15, you're going to get the data on incomes of each and every person, eh? And you'll be required to compute a mean. Is that not the quantitative analysis? It is. You'll be required to compute a standard deviation. You'll be required to indicate what the range is. That is quantitative analysis. So quantitative analysis does not mean quantitative research, because the experimental research is sometimes referred as quantitative studies or quantitative research, but that does not mean that in description there is no quantitative analysis. Okay. Then, so we looked at the various surveys. We talked about descriptive surveys, explanatory surveys. We talked about it, surveys of tangibles, intangibles. We discussed issues of validity, reliability, which must be kids stuff for us now. Are they not kids stuff? When if somebody says, "What is validity?" Even if we're sleeping, we should be able to. What is the reliability? Yeah, at 4 a.m. when we're just waking up, we can just shout. Then we talked about these developmental studies that my colleague asked about, where we said one type of developmental studies is longitudinal studies, cross-sectional studies, follow-up studies, documentary analysis, trend analysis, and I think that's where we stopped. Today, we are going to be talking about correlational studies. And when we talk about correlational studies, we are referring to studies where your interest is to look at the association which exists between two variables. It could be between two or more variables, but for now, let's talk about two variables. You want to assess the extent and direction of relationship between two variables. So in correlation studies, if you have conducted a correlation study, you must come up with two outputs from that bullet. One bullet, one output will be about extent of relationship. The other output will be about direction of the output. So if you conduct a correlation study, when you are interpreting the results or when you are discussing the results, you should discuss them in terms of what is the strength of association, that is the extent of association, and you should also be able to describe what is the direction of association. So the extent to which the variations in one variable are associated with variations in another variable, that's the strength we are talking about, the extent we are talking about. If you change or you increase by 10% in variable A, what will be the response in variable B? Are you going to experience another increase by 10%? Or are you going to experience decrease by 10%? Or is it going to be increased by 50%, decrease by 20%, what kind of association are you going to be getting. That's the extent of association. The second thing, if you increase in one variable, is that going to result in increase in the other variable? Or is it going to lead into decrease? Because if you increase results to increase, then you have a positive association. But if you increase results to decrease in another variable, you have a negative association. So those are the two stories you must talk about in correlation. There are two ways of assessing correlation. One way is by using what we call scatter plots or scattergrams, and the other way is by using correlation coefficients. I hope I can remove this. Let's assume you conducted an experiment. Like this one is doing here. You are a lecturer at the University of Lilongwe, and you teach research methods. You also teach statistics to the same class. And you had a question to say, if students achieve high in research methods, would that mean that their achievement in statistics is also going to be high? If students achieve low in research methods, are they also going to be achieving low in statistics? Now you have two variables, right? Achievement in research methods and achievement in statistics. If you administered a test, and let's assume you had 500 students, you administered a test in research methods, and you administered a research in statistics. And after marking, you decide to plot the results. So here you have research methods, results, methods. And this axis is about statistics. Jeffrey got 50 in statistics and got 65 in research methods. So it means that the performance of Jeffrey is there. From that spot, you can know, he got 50 and he got 65. James got 45, and in the research methods, he got 50. And you can keep on plotting each student's scores in that way for all the 500 students. And let's say that when you plotted, this is what came out. Each dot is representing two scores for a student. Right? Each dot is representing a student and his two scores or her two scores. This graph which I've drawn is what is referred to as a scatter plot, or some people talk about scattergram. It's the same. Okay? And from this scatter plot, there is a story you can say about the performance of these students. You obviously can notice that the students who are performing low in research methods are also performing low in statistics. Students who are performing high in statistics are also performing high in research methods. So you can actually say that these two courses, the performance in these two courses is associated in a certain way. Increase in one variable is associated with increase in another variable. So one of the stories which I said you should be able to bring out will be that one. There is an association whereby increase in one variable is associated with increase in another variable. You are talking about the direction of that association. The other story is about the extent, which I said, and that extent of association refers to how strongly associated are these two variables. If they were very strongly associated, you should have had a situation which is like that. Straight line. Meaning that proportionate increase in research methods is associated with proportionate increase in statistics. But this one you are seeing that we could draw that line, straight line. But in that line, there are cases like this one here, cases like that one there, who is not falling on this line. Meaning that in this is scatter plot, there is some degree of variation from the line. The degree of variation, so all these people are variating from the line. And that variance is being caused by another variable you don't know because you didn't include it here. But still, this is telling you that there is an association between statistics and research methods, and it is a positive association. Now, the closer the scores fall on the mean line, the stronger the association. The further away scores fall from the mean line, mind you, I'm not talking about a mean 8, I'm talking about a mean line. It's a line now. So the further away they are falling from the mean line, the weaker the association. So those two stories, direction and strength. Can I remove those and bring another graph? Let's say the association you got was like this. Now the line has changed its direction. Instead of going that way, it's moving that way. Meaning that high scores in statistics are associated with low scores in research methods. High scores in research methods are associated with low scores in statistics. So increasing in one variable results in decreasing in another variable. If you have that kind of situation, then we talk about a negative association. Okay? But in terms of strength, the same concept I talked about in positive is the same. The further away these scores are falling away from the mean line, the weaker the association. The closer they fall to the mean line, the stronger the association. Sure. Questions? Yakoneka kuti tuzu amazimva rwamhere akuzinjoya. He's enjoying. Eh? Any questions? So that's one way of assessing correlation studies. You look at the two variables, and the question you are dealing with is, are they associated? Is change in one variable associated with change in another variable? By the way, most of the research questions we deal with look at this kind of relationships between variables. Questions? So scatter plots is one way of assessing correlation. Another way of assessing correlation is using mathematical procedures. When you are using mathematical procedures, you come up with more precise measures of the strength of that association. Yes. Negative association. When increase in one variable is associated with decrease in the other variable, then that is a negative association. One good example is if you wanted to look at the strengths of people. Let's assume that you want to measure the strength of people by the way they are able to lift weights versus age. And let's assume that you are doing this study among people whose age ranges from 5 to 30 years of age. The amount of weight that a 5-year-old boy can carry, is it the same as the weight that a 10-year-old boy can carry? No. What you expect is the younger the boy or the person, the less the weight he or she can carry. The older the person, the heavier the weight he or she can carry. So in that way, you are getting this kind of association. This is age, this is weight. So when the person is getting older, the amount of weight he is able to carry increases. But the younger the people, the weight they carry is less. So you have a positive association. Now let's assume we are doing the same experiment, but now the people you are dealing with are of age ranges from 50 to 80. Is this going to be the case? No. The older, the less they can carry. The younger, the more they can carry. So now you get a different kind of association, which will be like that. As the age is increasing, the weight is decreasing. As the age is decreasing, the weight is increasing. So yeah, here you have a negative association. Have I answered your question? Yes. Yes, ask. Yes, yes. What's the? Okay, this one we're saying negative. I was responding to her question, whereby she was saying, when you are showing a negative, what do you mean? So I was saying, when you have a situation where one variable is uh, associated in a negative way with another variable. For example, age associated with his physical strength. But when the ages are older people age, then the older you get, the less weight you can carry. The younger you are, the more weight you can carry. That kind of association, which is like that one, is a negative one. But if you're looking at a younger population, the older you get, the more weight you can carry. The younger you get, the less weight you can carry. So you have a positive association. Happy? And I was saying another way, maybe 5 minutes, 5 minutes, stretch ourselves before we can start talking mathematics. You are assessing. If you have variables whose scores are measured in continuous type, then you use Pearson R, which is also referred to as product moment correlation coefficient. If the scores you are looking at are continuous data like marks, income, age, which you can have 1, 2, 3, 4, 5, 6, 7, 8. And the difference between 1 and 2 is the same difference between 2 and 3. Right? 2 minus 1 equals 1. 3 minus 2 equals 1. These differences are equal. Then you can use Pearson R, which is also referred to as product moment correlation coefficient. But that one can only be used when the two variables you associated have continuous data. Okay? If you are in a situation where the data is not continuous, instead it is ordered, rank ordered. For example, I've administered an exam in research methods in this class, and one student, okay, can I move this? Oh, you probably have not said yes, I've already removed it. Let's say a student got 90, another one 88, 86, 84, 83, 80, 79, and so on and so forth. Then I decide to say, who is number one in this class? So this one is number one, right? This is 2, 3, 4, In this, I have two types of data for the same students. The first data is the actual marks, and this data is continuous. The one who has scored 90 has scored 10 marks above the one who has scored 80. And the one who has scored 80 has scored 10 marks above the one who has scored 70. The difference between the 70 and the 80 is the same difference between 80 and 90. Okay? But by converting them into positions, then I've created a different measurement scale, which is ordinal. The differences which are here do not mean anything apart from position. Okay? And the difference between 1 and 2 is not the same as the difference between 2 and 3. Because if you go to the original marks, the difference between 2 and 3 is 2 marks, right? The difference between, oh, this one is also 2 marks. Yeah. The difference between 4 and 5 is 1 mark. The difference between 4 and 3 is 2 marks. So the differences that are here are not the same as the differences in the actual attribute being measured. Okay? So you cannot use these differences to mean anything. They are just giving you information about the order in which the students are coming. Now, if you have two variables that are ranked in order like that, let's say we had mathematics and statistics, and you ordered mathematics, we had the research methods and statistics, right? We ordered the research methods this way, and then statistics we also ordered depending on the marks. So now we are comparing the rank ordered data. You cannot use the Pearson R. Then you use the rank correlation coefficient, which looks at the differences in the positions. Okay? You may also have situations where you are comparing nominal. Nominal data is the data where the numbers do not mean anything, but they stand for categories. For example, if you are dealing with a question to say, is there a difference in the income status of students between male students and female students? Now, one variable is sex, right? Male versus female. The other variable is income. Income will be continuous data, but sex is nominal. You may decide to allocate 1 to stand for women, 2 to stand for men. But the 2 is not twice as much as 1. No, it's just a label. So in that case, you use other types of correlation coefficients to assess the association. Okay? Now, when you use the correlation coefficients, the results you get will always range from -1 to 1. When you get a correlation coefficient which is closer to 1, let's say 0.95, 0.89, it means that the strength of the association is high. In fact, if you get a correlation coefficient of 1, it's normally referred to as a perfect correlation. It is a straight line. this kind of correlation will be 1. But when you start getting some scores falling off that line, then it will be 0.89, 0.7, 0.6, 0.5. When you are approaching 0, it means there is no correlation. Actually, 0 stands for no correlation. But this side, all the correlation is positive, right? And this side, all the correlation is negative. So if you get negative 0.98, 0.89 negative, it means that the association is this type. Okay? If you get positive, the association is of that type. So you can describe the two aspects which you talked about using the correlation coefficients. Questions? Clear? What? Oh, this one. Which? This one? The Pearson? No, there's no abbreviation for that. This one? Oh, you are talking about the full name. Correlation coefficient. Product moment correlation coefficient. And the other one I talked about relating to rank ordered data is the rank correlation coefficient or Spearman law. So if you are conducting, if you want to assess the correlation coefficients on the computer, you have entered your data on the computer and you want to get the correlation coefficients, it will show you R. R, it refers to Pearson R. If it is rank ordered, it will say Spearman law. But these are the choices you must make. It is not the computer telling you. You are the one who knows the type of data which you have entered. The computer, if you give it a rank ordered data and you say Pearson R, it will give you R, but it will give you junk because you have not given it the right instruction. The right instruction is what we are discussing here. Questions? So correlation studies, I think I jumped one bullet here, can be classified as descriptive when your interest is purely to describe the relationship. But you can also go to the level of hypothesis testing of those correlational studies, and then you'll be doing ex post facto studies. Sorry, there is a mistake in my spelling here. I already sent these slides, right? This is not fact. Make corrections in your notes. It is a factor. Okay? Ex post facto correlation coefficient. But hypothesis testing should be based in your prior knowledge about the type of association. You remember when we were talking about hypothesis, we said you need the literature review it to support. So that's what I'm referring to here. And you can make, and if you have to make inferences to, let's say you use the sample to conduct those correlation coefficients, but you want to infer to the population, make sure that the sample you come up with is very representative of the population. Because if it is not representative, it can actually end up depressing your correlation coefficient. We saw that kind of association is where generally increase in this variable is associated with increase in this variable. Now let's assume that this is the data you have generated from the population. But since you don't have, this is the data which exists in the population. But since you don't have time, you have just decided to use a sample. And if you take a sample from this group here, it's a sample representing the population age. But look at the correlation which will occur here. It will appear as if the scores are falling very far away from the mean line, meaning that there's no correlation, there's very weak correlation. But it's just because the sample you came up with is not represented. These guys who are on the other side have not been represented in that sample. Okay? So when you're doing correlation studies, pay attention on your sampling procedures. Otherwise, you may end up restricting the range of your correlation coefficient. Is that making sense? And if you have conducted a correlation study, and let's say you are finding very strong association, like we said one is perfect, but that association will not be telling you that one variable is causing another variable. It doesn't say that change in one variable is causing change in another variable. It's only telling you that change in one variable is associated with change in another variable. So never interpret correlation as causation. No, it's association. Okay? Cause effect relationships are assessed using experimental studies. Okay? I think we are now in a fight with nature. But I'm saying that no matter how strong the correlation is, the association is, never interpret that strength of association as causation. It is only telling you that they are associated. Let me give you one example. In that test where we tested performance in statistics and performance in research methods, and if we found that those students who are getting high scores in research methods are also getting high scores in statistics. Does it mean that the high scores in research methods are causing high scores in statistics? No. There is another variable, which is intelligence coefficient, IQ, which is making those who are getting lower scores in